Aashka here.
And welcome to the fourth lecture in the Basics of Library and Information Science, Information Ecologies.
When we think of the word ecology, we're often thinking about the hard sciences. We're thinking about the field of ecology or the study of the relationships between living organisms, including humans and their physical environment. That said, we can also interpret ecology more broadly. The key concept behind ecology is that it's the study of relationships between interrelated concepts, and this is a logic that can also be applied to the social sciences. Media ecology refers to the interactions of communications media, technology, technique, and processes with human feelings, thoughts, values, and behavior. Information ecology refers to a system of people, practices, values, and technologies in a particular environment. In information ecologies, the spotlight is not on technology, but on human activities that are served by technology.
When thinking about information ecosystems, it's important to remember two concepts: technological determinism and social constructivism, which we can think about as a spectrum of causality around the effects of technology upon our society. Technological determinism refers to the idea that technology determines our behaviors. When people say that violent video games make kids violent, they are using a technologically deterministic thought process. Conversely, social constructivism sits on the other end of the spectrum. When we use a social constructivist approach, we may say something like a child's environment, including their home life and experiences at school, informed how violent they became. In reality, things are a bit more complex. For example, research has found that there is a link between youth playing video games and experiencing symptoms of depression, and between college students playing video games and experiencing more aggressive thoughts, feelings, or behaviors. However, violent video games are not the only cause of violent behavior. Other factors such as neighborhoods, families, friends, and a given child's personal situation can also influence violent behavior. And the overarching cultural context and environments also created the video games in the first place. Is there a correlation between violent video games and violent behavior in use? Yes. Is it also true that the other factors are also at play here? Yes. A lot of our society is filled with complicated situations like this one, and it's helpful to think about these scenarios along a spectrum of technological determinism and social constructivism.
Actor network theory is a prominent theory that helps us think through the making of science and technology. Imagine a group of nodes or actors connected in a network. Each of these nodes influences the others, though there is more distance from some nodes than others. Ultimately, there are influences from all actors in the network across and throughout a network. Actor network theory is particularly helpful when thinking about the idea of black boxes. A black box can be almost any type of technological object: a car, a TV, a phone, a large language model like ChatGPT that works the way it should. When these devices work, we don't necessarily pay attention to the socio-technical relationships that these technologies are leveraging. They're more or less invisible or black boxed. It's only when the system stops working that we notice its role in our lives. Let's take travel as an example. Maybe you're about to take a plane. You want to make sure that you have your boarding pass on hand for your flight. These days, most people would have their boarding pass appear on their phone. But maybe you're in another country and your phone isn't working. You might want to go to a local coffee shop to use their Wi-Fi, or you may decide to print your boarding pass at the airport instead. If the coffee shop is closed since your flight is early in the morning, your only option might be to get your boarding pass at the airport. In this example, a bunch of social technical relationships become apparent. Our need for a boarding pass or a barcode uniquely tied to our names to get on the plane, our reliance on private coffee shops for public internet access, and the fact that even though we may not use them all the time, printers can still be a really valuable resource. Another example can be the AI systems or large language models like ChatGPT, Gemini, and Copilot. When these systems work by surfacing a quick answer to a question or troubleshooting our code, they can be a huge help, and we don't really think about what's happening behind the scenes. When these systems don't work, let's say they hallucinate a source or give you directions to the wrong place, they can hinder our lives in major or minor ways, which become quickly apparent. According to Ruha Benjamin, a glitch like that helps us see how cultural norms and practices inform our technical systems. They are not, in fact, accidents, but features.
A bit of background here. Actor network theory came into shape in the 1980s, and it was created by social researchers at Mind Paris PSL, or Paris School of Mines. The theory has broad relations with humanities thinking and postmodern philosophy at the time, and researchers initially developed it to understand how innovations in technology and engineering came into being. Because nodes or actors and their relations are such compatible metaphors, this framework turns out very useful for thinking of not only technological objects, but broader social and material relations. Using actor networks, sometimes dubbed actin networks, we can really go beyond just human actors and account for various forms of non-human, mechanical, and material forces that shape things into the form that we know. This is, again, aligning with postmodern thoughts that are moving away from hierarchical human-first thinking into a world where everything is laterally interconnected and interdependent. For example, early natural sciences and engineering usually pose humans as the center of agency, that humans, and only humans, are able to think of ideas, rearrange materials, create machines, and make use of the natural world. Postmodern and more recently post-human thoughts rebuke this kind of human exceptionalism, instead arguing that we and things that we create are only part of a thickly interconnected world. We are constantly influencing and being influenced by each other with our respective goals and motivations or projects. Even a piece of stone or a metal block has its own project, meaning its qualities and tendencies can influence how others interact with it in the network. Thinking in a network way, there's no longer a clear division between natural and artificial, between non-human and human, or between so-called nature and nurture. There's no longer a center of agency. In addition, this viewpoint is also useful for post-colonial and decolonization studies, where Western colonizers previously saw colonized people not as equal human, but as part of an undeveloped natural world, quote-unquote, that was lying in wait for Western people to develop and exploit. Acton theory, as well as its broad humanities counterparts, is really about acknowledging potentials, studying connections, and setting free.
So, how do we apply actor network theory when thinking of information ecologies?
Here are the two concepts that can help us apply actor network theory to our relationships in and around information ecosystems: affordances and constraints. Affordances are attributes of a setting which provide potential for action. Constraints are conditions and relationships among those attributes that provide structure and guidance for action. That sounds a little bit technical, right? So let's break it down. Let's think about YouTube for a moment. What are some of its affordances? Attributes of YouTube are that it allows people all over the world to upload videos, which are freely available to watch. This setup affords us the potential to watch videos for a variety of purposes, including education and entertainment. At the same time, YouTube does have some constraints. If you find a YouTube video that you'd like to share, you can use the platform's affordances to share links to various platforms online. You cannot, however, download a video directly from the platform. This constraint may be in place to preserve the authenticity of the videos or to make sure that users keep coming back to YouTube for their video watching. Perhaps there's a middleman service that will help you download the video, but that is an affordance outside of YouTube, which is leveraging the constraint presented by YouTube itself.
A good tool to study information ecosystems is an ecosystem map. There are a lot of moving parts around our information ecosystems, including users, the communities around those users, the systems that we need to scaffold certain technologies and information systems, and the institutions that govern and organize our actions, such as universities, governments, and corporations, through their practices and policies. To start, think about a given user in an information ecosystem. For example, let's say our user is an UNC undergraduate student who wants access to course materials to study for an exam. This student needs to know where to go to find those materials, how to log in, which means they already need to have an onion, and how to navigate Canvas to find the materials that they need. We can also think about how this student is feeling. They might be stressed about their exam. They might feel confident in their ability to study for it. They might be feeling a mix of emotions. Either way, a lot of their behavior and their ability to do well on the exam relies on the student in question being able to navigate this information ecosystem. Around that student are their communities, their classmates, their teaching assistants, their instructors, and other students at UNC who may have taken the class before or may take it in the future. These groups of people can play an important role in the student's life right now. For each of these groups, we can consider how they help the student by forming study groups, for example, or block the student's access by not uploading materials to Canvas, say. There are also a lot of power dynamics to consider here. The professor or instructor has set the agenda for the course, knows what's on the exam, and is working with the TAs, who in turn are working with students during recitations or labs. If there's a weak link in this pipeline, perhaps one of the TAs is out because they're sick or the professor has uploaded the wrong files to Canvas, power dynamics become apparent. At this point, we can start thinking about potential changes to the information ecosystem to help prevent pain points or to make the system work better.
And of course, there is a huge technological service at play here at UNC. Canvas. If Canvas goes down for the entire university, almost all coursework will come to a halt. If you as a student haven't downloaded all your materials ahead of time, this will severely constrain your ability to study for the exam. If it's hard for you to create an onion, then you might not be able to log into Canvas to begin with. University ITS is an institutional group that helps manage this. They maintain the internet at UNC, provides guides on how to get started with an onion, and have a chat service for UNC community members who are having technical troubles. At the institutional level, we should start thinking about systems and policies that affect a student's ability to successfully take this exam. The university's policy to provide free on-campus internet is certainly a huge determining factor here, as is the energy utility company's practice of providing regular electricity. There might be unequal barriers or access here if a student is remote and their Wi-Fi at home is not as good as Wi-Fi on the university campus. There may also be barriers if a student is speaking English as a second language and they are new to reading academic papers and articles. We should consider the affordances and constraints within our institutions as we map our information ecosystem. At this point, you're equipped to think about an information ecosystem that is prevalent in your life. Maybe it's this class and all the students in it, meeting together in a digital workspace. What are the affordances and constraints of that ecosystem? Who are the major actors in that ecosystem?
Thinking about ecosystems in information helps us understand how interconnected our information ecosystems are, helping us to think of big pictures and helping us better understand a lot of wicked systems problems that characterize life today.
Ecosystem maps are just one of the methods that we can use in design thinking or human-centered design. In next week's lecture, we are going to explore design in more detail, so stay tuned.
Until then, stay informed
and stay well.
Peace.